bear with us. We're about to start with a short video. After that, Mandana from TU Munich, Technical University Munich, will explain the SSD approach to combine different data types, exchange data, manage sources and harmonize information in such a way that integrated assessments and decisions can be made. Then Holger from TU Berlin will illustrate his experiences with applying this approach within various districts. As I said, during the presentations, you can ask any questions at any time by typing them into the chat box on the side menu. We'll address clarifications directly after each presentation, and other questions we'll come back to with some more discussion following both presentations. The main webinar will last an hour and will be recorded. And after that, there's another half an hour or so if you want to stay online and ask further questions and engage with the presenters. So on that note, I'll switch to our esteemed colleagues in Utrecht, the Sustainability Institute, Martine and Arno, who have done a fantastic job, and thank you guys for organising the session today. And they've got a little introduction video to share with you.
By 2050, 75% of the global population will live in cities. In the face of urbanization and climate change, many cities have committed to ambitious climate mitigation and sustainable energy goals. Districts are the most effective unit of scale at which to test integrated systems and infrastructure and accelerate sustainability. In the process from ambitions and visions to urban transformation, almost all districts are dealing with data issues. It is a major challenge to combine different data types, exchange data, manage sources, and harmonize information in such a way that integrated assessments and decisions can be made. Data-driven district transformation is a proven approach in the Smart Sustainable Districts network. Districts in Utrecht, Berlin, London and Paris have successfully integrated various data into a harmonized approach for sustainable urban transformation projects. Data-driven district transformation enables district stakeholders and international experts to design smart, sustainable and resilient cities through co-creation, easily exchange data with each other and external stakeholders, calculate integrated solutions, visualize and facilitate communication to engage citizens. Smart Sustainable Districts is a group of pioneering city districts working together to deploy and accelerate the knowledge, expertise and best practice needed to transition to zero carbon living and build resilience into Europe's cities. The SSD network offers support and services to create the dialogue, test the beneficial impact and help realize sustainable district-led development.
Thanks a lot, team. And if you are joining us via the recording of this webinar, it's Tim Taylor here from Climate-KIC in London, and we've just played an introductory video, the link which will be shared with the recording of the webinar, so I encourage you to check that out. For everyone else and in real time, as I said, the first speaker for today is Mandana from Technical University of Munich. She's a research assistant in the chair of Geoinformatics. Mandana has a background in natural resource management, environmental engineering, computer-aided facility management, and is now working in the field of geospatial data management. She's been involved in the Smart Sustainable Districts program since 2015 as the leader of the data integration workstream on behalf of Professor Thomas Kolbe. As part of her work in Smart Sustainable Districts, she has been in close collaboration with all 4 of the districts that have been worked with most intensively so far in the program. And she's also active in network activities, working with other districts as they come and participate in the program. She continues her role in Smart Sustainable Districts as the leader of the data integration workstream. And with that, I have great pleasure in introducing Mandana to take you through her presentation over the next quarter of an hour or so. Enjoy.
Okay, thanks for the introduction, team. So I guess everybody can see my screen, yes? Okay, so I don't think it's necessary to give an introduction on the idea behind the smart cities, as we are all aware of the concept of the smart cities and its importance. Also, we all know that the role of data and information is crucial for the transition of cities and districts to transform their district to a smart and sustainable future. Although this is not a new topic, we are still facing many challenges. So here I listed some of these challenges. For example, there are many strategies, many solutions in the market for dealing with smart city issues, but these are focused on the technology rather than practicality. For example, it's a case that one IT company which is not aware of many other aspects such as social aspects of the problem sets up the system for the city, and this is actually pointing out to another main challenge, which is that these solutions are often top-down solutions, and of course they are proprietary. Another challenge which happens out of this top-down process is the lack of well-designed information infrastructure, which leads in incompatibility of the services. It's very important that we understand that we don't have only the district owner or the municipality as the stakeholder in the district, but we have many various stakeholders that they have different roles and interests in the district, and often it happens that their interests and role are overlooked. So focusing on the district scale, the current situation is like this, that we have different stakeholders such as citizens, municipality, different utility service providers, and they are interested in different applications. And for these applications, we need different tools, and without any doubt, we need lots of input data. So by looking at all of these components together, we see that we have a network of distributed systems which is quite complex, and to manage such a complex distributed system, districts are in need of a suitable data integration infrastructure. So the district is interested in having a uniform and standard data framework, and actually all of these points which are listed in this slide are from the experience we gained in the last 2 years with working with different districts within Europe. So the district is interested in having a uniform and standard data framework which takes into account the roles and interests of the various stakeholders involved in the process of the district. One key characteristic of such data integration is interoperability, and this can be guaranteed by using open standards. It's very important that we understand this current challenge of the district, that they don't want to be locked in one vendor, so the solution should be vendor neutral. Another point is avoiding data redundancy. What we experienced in the last 2 years working with different use cases was that in different use cases more than 50% of the required data are common. So it's very important to understand the overlaps and also the gaps. And of course, the security and the privacy of data is one of the main challenges in the current situation. And of course, the data integration framework should be flexible, extendable, scalable, and transferable, by which we can transfer our solution to different districts and urban areas. So going back to this complex distributed system, in order to break down its complexity, we need to categorize its various components, which leads to the concept of a smart district data infrastructure, in short SDDI. So many of you maybe have seen this diagram, which we recently updated the diagram, and this is the recent version of the SDDI concept. So the SDDI consists of 6 main parts: actors, applications, urban analytic toolkit, virtual district model, which consists of the 3D district model, networks, and the visualization of the physical objects of the district, sensors and sensor data, and in another way, the Internet of Things, and the catalog service, where we register all the resources, tools, and data of the district. So in order to implement this concept, we need to define a process with the goal of having an open distributed system in mind. And to do so, we use the ISO standard 100-746 Open Distributed Processing Reference Model. This ISO standard provides 5 different views by which we can look at our system and understand the process of the system. So the way we adopt this ISO standard for our process in SSD is categorized in 3 different steps. Started with enterprise view, by which we try to understand the stakeholders, different partners involved in the process of the district, and we try to understand what are their interests, and by which we try to find the use cases. And after defining the use cases, we define which data are required for those use cases. Then in the second step, in the information viewpoint, we try to categorize this data by using standard data structures and formats. And then one of the most important parts is engineering viewpoint, where we try to harmonize the exchange of the information between different components and parts of the system. And computational viewpoint, which defines the flow of information. And in the third step, we try to define this configuration we did in the last 2 steps for the district, and define which hardwares and softwares are required, and define the different scenarios and try to give like a rough estimation of the cost for different scenarios. So to give you an impression of how this process works, let's look at the example of KOP. KOP is a sporting complex built for the 2012 Summer Olympics, and now they want to add more functionalities to these districts. So within the SSD, we defined 4 key themes: resource efficient buildings, energy system, smart park, and the 4th one is the data architecture and management, which underpins the other 3. In one of the first workshops we had in the districts, each of these 3, let's say, use cases define the data they need to work with, and then we try to combine these lists together. So here you see this list where we try to put out those redundant data, and then we try to figure out how this data should be provided and structured. So what we did was define the different categorization for this data, and interestingly, for all these 3 use cases, some of the elements in virtual district model and sensors were used and required. So as an example, one use case was the pedestrian flow simulation. I'm not going to explain the technical part of this diagram, but what I want to show you is that imagine you are in the position of the developer for the pedestrian flow simulation. The first things that you need is to know the data you need for your simulation are available, and how and from whom you should get this data. So the key point here is the catalog service, where you query the data you require for your simulation and see who is offering this data. Another point here is that you see, just only for this simulation, we need 3 different sets of the data, and they are different. So imagine we have 3 different sensor providers. They have their own structure for the data and the way they define their data. And you can imagine how hard it can be for the developer to understand individual structure of all these data sets. So what we suggest here is to create an intermediate interface by which developer just need to understand this intermediate and communicate by this interface or through this interface with different data sets. So for the sensor, we use OGC sensor observation service. For the geospatial data such as buildings and roads, we are using web feature service. If it's still not clear for you, so let me show you a demonstration of this implementation. So I hope that you can see. So here is what we call it catalog service. So it's like all the services we work with at the moment in the KIC district are registered. So these are not all the resources we have, but few of them. So and you can search using different keywords. So what I want to show you is the visualization client of the sensor observation service. See, if I click here, I see the description of which data are provided by this service, the direct link to the web client, the keywords, and the metadata which has more information. And also here you can see the boundary of the area this service is applied for. So if I open on this link, what I see here is the KIC. So if I zoom out, here is the area we work, and we have at the moment 6 sensors registered. So if, for example, let me show from here. So if I click on these sensors, so I see the station name. So it's provided by ICRI, which is the Intel. The same, for example, for this station. And maybe you ask, okay, what's the benefit? So Intel can provide the same user interface that you can have the information. But the interesting point is where you have more than one provider. So here, look at this. It's the station and the data provided by NG. So what this OS makes is that harmonize different data sets and different types of the information in a standard way, which gives the possibility to the other users to only work with this interface, which is SOS at the moment. So if I click on the station, here is the list of all parameters that this station offers. So if I choose, for example, electricity consumptions and gas consumptions, it goes to the diagram view, and I can give different colors so you can see the difference. And this information are collected per half an hour, so you see it's 23rd, and that's the time here. And here is also another view in tabular format. So if I go and I wanted also to, for example, compare or bring another information here, add the Intel sensor and, for example, choose the outside temperature, it's also possible. So giving another color, going back the time. So here we see how friendly we can combine the information from different sources together. So if I still have time, I would like also to show, for example, another implementation, which is the 3D City web client for the KIC. Again, the same structure. And if I go to the web page, here is another web client we set up for the KIC, which visualizes the the 3D district objects of the KIC, and when you click on any of these objects, you get a set of information which you already added for that, for example. So for example, if I click on the stadium, here I get the information, and this information are stored, for example, in the spreadsheet. So later when the developer wants to work with this information and develop different applications, all this information are stored in an interoperable way, and they can be queried also. So far this is my presentation.
Thanks, Mandana. Firstly, at this point, we've got Jim from QEOP on the webinar. So, Jim, reflections from your side from a district that's been in the program for a couple of years.
Yeah, so what Mandana went through, is really how we first started working with TUM. I don't know which aspects you are interested in, but when we first started working with the SSD, we quickly identified that data was going to be something which we needed to take as a separate work stream, and that's why we separated it out separately to the use cases. And we had a couple of workshops really looking at how we could best manage the data and to put it in a single data model, or at least a data model which would cover all the types of data that we were going to collect on the park, because we knew we'd be collecting an awful lot. And I think you saw the screenshot of the whiteboard which was put up, and we just felt that the TUM team who were at the workshop really understood and managed to pick out a sense of order from what was quite a messy flow of information and just random pieces of information and data which we knew that we'd be able to collect. And so we've been really pleased with the way that TUM have really addressed that challenge of ours to SSD as a sort of like a community, which was how do we manage all this data which we're going to start collecting. And as a couple of the use cases which Mandana went through, we're starting to use this data operationally, and as we collect more data, having it in a single data in a single data model means to say that we can start using dashboards and 3D modeling to look at different types of data, and that's something which we're really excited about being able to do and to progress into the future. I guess so our challenge is really we're collecting the data, and still some of those sensors don't feed in a continual stream of data because they're being put together by researchers. So that's a challenge for us from an operational point of view, is making sure that we have a continual stream of data without any breaks in it. The other challenge with the data model, which is what TUM covered, which was really good, and then I guess the challenge which is still outstanding really is that where do we put this data? And I know that TUM are working with another third party company looking at how to put together a productionized and industry strength data repository package, so that when the research students stop working on the SSD program with us, that we've got a company which will make sure that that database carries on working. And obviously it's not just the database, it's all the web services around it. So I guess that's the challenge which we're all working on at the moment.
Very good. And while we've got you, Jim, there's a number of people on the line and on the webinar from other districts and other cities. So what are some of the ways that this is turning into benefits on the ground in the systems for the community in QEOP?
So we're using data in a variety of different ways. Not all of it is necessarily held in the TUM data repository, but it's all covered by the model. So there's quantitative data which we're collecting, so that's data from the sensors, energy data from the different venues, and also our district energy networks. So we've been concentrating looking at the data which comes from the energy usage in the venues, and we've been identifying with the operators of the venue, with the two venues we've looked at, how to reduce the energy impact. And although when the venues were built they had building management systems in them, no one was really using them to certainly on the reduction of energy use side. And this project has really enabled us to shave a lot of energy and therefore cost off of running those venues, which is really good. And also we have a district energy network around the Olympic Park, and we're looking at different energy or different sensor points along that network to see how we can make that more optimized. We're also looking at footfall across the park. So we have a public Wi-Fi system across the park which people sign up to. So we can, by tracking phones around the park, we can do, or any Wi-Fi enabled device, we can tell visitor flows around the park, which is especially useful for when we have very large events. We got a football stadium on the park which has got a capacity of about 55,000, and as you might imagine, so every fortnight we get a lot of people who come onto the park at very short periods, and we're looking at how they move around the park and looking at how we can maybe push people to transport hubs which aren't the most obvious for the park, improving both their experience of visiting the park and also from a safety point of view. And on the qualitative side, we're looking at picking up social media feeds, Twitter and Facebook, Instagram across the park, and also we've run with University College London something called VoxBox, which is basically a device which people can interact with using sort of levers and dials, which ask them questions about how they're enjoying the park, but it gives us a lot of useful information about how people are enjoying the park and what's good and what's bad about it at a particular point in time. And then the other thing we're doing is creating, and all that goes into how we operate the park and how we market the park. The different sensors on the environment and biodiversity. So we're about to implement bat sensors to track bats around the park, and that's very important for us from a sustainability point of view, because we need to show how we are running the park in a sustainable way. And then the other way that we're looking at this is the 3D maps of the park and virtual reality views of the park, which we can use both to show people what the park is like now, but also starting to use it to put in, for instance, we're doing a lot of housing and other development on the park, building development, so we can start to show people what they will look like in the future. So there's a lot of use cases, and as we share what we're doing and the data which we're collecting with our colleagues within the business units at our organisation, they come up with other use cases which they feel would be really useful, especially in the way that we engage with our park visitors and also the residents of the local community.
Great. Thank you, Jim. It's really helpful to have that, user and customer perspective, and turning these into practical, both qualitative and quantitative projects and benefits. So thank you. Again, if anyone else, if you've got some questions for Mandana, then feel free to write them into the questions box on the right-hand side. But I think we will continue on, and I'll introduce Holger. Holger's works with the interdisciplinary team at CORA, the Conscious City Lab, the Sustainable Planning and Urban Design team with Professor Bunschutten at Technical University of Berlin. He has a background in media technology and architecture. Holger was already involved in the Climate-KIC project modelling city systems, and with Smart Sustainable Districts he has experience from his work on the District Data Atlas project as part of the Berlin Moabit district. And as systems architect and data scientist, he is now mainly involved in the development of data-driven solutions and knowledge management tools that support the collaboration and negotiation processes in districts. Holger.
Hi Tim, thank you very much for the introduction. Yeah, I'm here in Berlin working at the TU Berlin, and I want to tell you something that we did with applying with the SDDI, the Smart Sustainable Smart District Data infrastructure. So what you see is it's just the view on our district. You see is quite heterogeneous area, lots of stakeholders involved. So mainly our effort was not optimizing single technical solutions, but more looking at the landscape of stakeholders, how to involve stakeholders, how to engage stakeholders and citizens, but also business. So this was our district, the outline of Moabit West in the northwest of Berlin. As you can see, we basically cut it in the same type we had a very similar structure than the colleagues in London. We also had a cross-cutting theme that we developed, or that we called the District Data Atlas, where we wanted to develop to provide a platform where all the different opportunities here, the different use cases could link together and basically communicate their findings, their potentials for sustainable solutions. And as you see, we also at the end, actually these four brackets on the bottom visualize the outcomes, the different projects that actually came out, and the color indicate that every solution basically also had a bit of another solution. So this was a refurbishment of a street, the Sickingstraße, where mobility, energy, and water management actually were all needed to be integrated into one solution. So basically there was a very fundamental need to share information also during the development process. Another solution was a mobility solution, a water management system, which also of course crossed with the energy efficiency, and another industry efficiency program, which also looked at energy and water management at the same time. So citizen engagement and district data atlas basically were the themes cutting through the three use cases. So I was mainly involved into development of this District Data Atlas. So we joined together with the TU Munich and the local company Virtual City Systems here in Berlin, and developed a platform basically based on the concept of SDDI, and we basically applied it and developed applications on top of it, focusing on the different use cases and different users, from professionals, from experts, but also up to citizens and other interest groups. So this is another visualization. So what we basically want to achieve is a platform that hosts all the data of all the experts in the project. So there wouldn't be any redundancies, and outcomes of one expert could be used as an input for another expert's analytics tool, but also could be shared on a platform and be looked at from other users. We also did this mapping. This is not really the most beautiful graphic, but I found it quite interesting because this is really the real applications that we mapped out. So we had car sensors, traffic sensors, and traffic data, water data, the data of the canalization system, a noise map, map for air pollution, and an energy data mapped out. So that was basically all hosted in our virtual district model and accessed by different applications. So we had another toolkit, which was a pedestrian modeling tool, a transport energy and emission calculation tool, a noise model, and a traffic model. Basically, using that data and also pushing back the results into the virtual district model. On the application side, we had participation tools like an online platform, and also workshops with digital tools that I will show later. Visualization, of course, now like a storm water management system that actually was that was developed with different components. So it was also an integrated solution with some low-tech and some high-tech technologies, and like more applications. I think I will show them later, like the screenshots, so you have a better idea. And of course the real actors that we dealt with during the project. So first of all, what we set up was the catalog service. After we had the infrastructure, the basic database infrastructure, we had this catalog service online where everyone of the development team could log in and access the data that was already provided by us, or also by the different experts. This is, for example, an accessibility map showing what areas are covered very good with the public transportation system and which one might need some development. Another example is this data that was available from the energy opportunity, showing the potential of a refurbishment model. So the darker green, the more energy saving potential you would get if you refurbish that place. We also had a 3D model running, so you could that was very interesting during planning activities. When we had stakeholders on a planning table, on our digital planning table, we had so you could visualize basically the area, could get more information about single buildings, like Mandana showed it already in the 3D client that the Munich has. This was all running on this open source technology, like the 3D city database, basically working as a data infrastructure backbone also for us, and also enabling. This would enable also other types of analytics toolkits that could link in and provide us on the same standard platform further information for different use cases. One use case that we also implemented was a street lighting simulation tool. We basically changed the street lamps, the existing gas lamps in Moabit through LED lamps, and got a real-time calculation in our web platform for like the energy savings, the implementation costs, and the emission savings. Another application was basically the participation platforms, because as I said, the stakeholder landscape was very diverse, and we really had a hard time getting everyone involved, getting like consents between different parties. So we had developed this method of a negotiation process where we have an online platform that we provide to citizens and also stakeholders, where they could upload and link in their personal interest of development, maybe some projects they already know, so we can basically crowdsource information from the district. As you can see, here is Moabit district, so we got a lot of feedback from that place. That information basically also linked to the STDI and would later be available in a digital workshop. But yeah, I will show you a bit later. This was another thing that was more specific, another website, like an issue tracker website, but we customized it for particular mobility questions. It was for e-bike sharing stations and other mobility issues in the district that also, of course, then link back to the STDI through open standards. So the data would be also available. I'm just showing these as different interfaces, because depending on each use case, you have to maybe adapt your strategy how to approach the client or the user. So not everyone can deal with the full depth of information. So you to engage citizens and also to kind of steer the process, you have to package different applications. This was another example. Oh, and I just see that you can't actually see the interactive table, but you will see it later. So this was a citizen engagement event in the district where we invited citizens to play with us and to discover different aspects about their city or about their district. So this now is the integration workshop method that we developed. Basically, that is the idea of this of the Conscious City Lab, an interactive environment that visualize data and make people aware, rise the knowledge level of visitors and of citizens, so we have a kind of equal level of discussion and not this expert perspective that citizens would then not be able to participate in a discussion. This was just a screenshot or a photo of a prototype of our lab that we set up also within the SSD process. This was on a big event here in Berlin, on a big smart city fair. But we also have it applied, or we used the method in another district in Utrecht, where we also been part in a smaller mobile version at the local participation festival, let's say. So we also, on the left side, you can see the map that we, the web platform that we published, and to collect information in the beginning of the process, and then invited stakeholders and citizens during the festival to negotiate and explore and negotiate different potentials about the site that was going to be developed. This picture I put in because we had a visitor from the mayor of Berlin paid us a visit and also played with our toy, let's say, our interactive table, and we are actually now about to establish the lab here in Berlin as a tool to host and to get experts and also non-experts together to discuss about developments in the city. One last application that is also inside the package, and that's also able because of we use the STDI, and like this we can basically publish it very fast, was a data story that we developed with a local newspaper. So we could we took out the findings of the district of Moabit and just expanded the analytics to like the accessibility analytics to the whole of Berlin. And we are now publishing this with a local newspaper as a digital media story. So we can get people we can make people sensitive about the topic and also make them understand that if they have the right knowledge, they can also participate and take a role in the process. So basically, this is just an overview of our achievements that we were able to reach because we used the STDI. I think I don't need to read that all, and I can just go to the next step. we plan now, because we have the SDDI implemented, we can now we are now thinking of extending our analytics toolbox. We are because of the APIs, the open APIs, we are able to link in these analytic toolkits rather easy. The resource box is basically the knowledge that we gain from the process that also sits in our database. This whole thing is going to be redesigned or reused as an educational setup, so we can educate the citizens and users of the districts and also of other districts and make them aware of the potentials of data use. Knowledge management, I said already, is a project that we also developing in SSD, so we can share the knowledge that we gain from between the districts. Machine learning, I think that's a very big topic, because if you don't, if you are not you don't have the power over your data inside the district, it's very hard to actually apply these new technologies, because if you don't have, if the data is locked in a proprietary system, you will not be able to gain all the insights from that data. So I think it's very important that the municipalities is in power of their own data, so they can later choose what applications they actually want to use, and also they are in the power of the insights that is lying inside the data. Yes. So yeah, and of course we are building up, or we are continuing to set up the lab, and I think now more and more cities are developing their own labs. So I think this is something, yeah, very interesting. Okay, I think that's from me. I hope I was in time. Thank you very much.
Thanks, Holger. All right, we have a question that has come in from Eduardo, and he's asking about, so to you both, that it seems from your presentations that the data collection is mostly dealing with general or publicly available data, but how within that and what data privacy issues, can you share how these are being managed, how you're getting data, I guess, from different sources that might not already be public, and how can this be managed? Can you share a couple of small examples?
Yeah, I mean, maybe Mandana can help me, but I can just say from my side how we deal with it. So the data in the servers is locked, and basically just through applications the data is accessible, and these different applications, like the catalog service that I'm showing now, is not not all the data is publicly available. So you have to have a login, and some data is more private, and some data is more public. And yeah.
Okay, so from the general process, if it's the question about how the difficulties about getting the data from those who are the private owner of the data, well, this is partly addressed in this process I showed, this enterprise view, where we try to sit with different stakeholders in the districts, and it's also part of the SSD process in general to make this trust between different stakeholders, and to see how we can define the benefits for all partners, and convince them that sharing the information could be helpful in general for their business and also for the districts and citizens. This is one part. From the technical point of view, using these interfaces, this in engineering point of view, this is quite helpful, because, for example, the example I showed you from KOP, the data from NG, they are not open data, they are kind of, let's say, private data for the NG company. First of all, it was the benefit we had from the LDC to talk to them and bring them into the process, but also setting up these interfaces by which we give this possibility to the data owner to set in which level they want to share their data and have control over their data could be also quite helpful in order to persuade them to share their data.
Yeah, it's Jim here, shall I just add to that?
Sure, thanks, Jim.
Yeah, so all the data which we're collecting is private at the moment. One of the things that we'll be looking at is which of the data sets we should open up for general access. The most obvious ones are things like the environmental sensors. Maybe some of them, like the energy usage within the venues, we wouldn't want to open up, but that's yet to be agreed with the business teams here. One thing I will say, though, is that London, from a city-wide point of view, the Greater London Authority has got a open data policy, really, and there's something called the London Data Store, which has lots and lots of data on all sorts of things relating to London. From school attainment to air quality sensor outputs, which is released to the general public. And in fact, you may well know that all of the underground and transport for London, things like bus timetables and real-time information on the transport network is released out into the public, so people can write applications to help Londoners navigate the city. So it's something we're looking at. Obviously, when it comes to data which is related to people, then obviously we have to be very, very careful with that, but we already hold as an organisation data relating to people, so we abide by the proper data protection rules for that.
Great, thanks, Jim.
And can I add also one more point? Technically, we can support from all public over password protection of individual resources to full support of single sign-on infrastructure using mainstream IT data security protocol like OAuth 2 and SAML. So it's just like some technical points also.
So another question we have is what makes the smart district data infrastructure different from other solutions that are available on the market?
So there are several key points. One is in the CDI, what we use is open standards, and by which we try to make an interoperable framework for the data, which is quite key element nowadays for the data integration framework. This also helps us to guarantee the transparency of the work and the data flow in the work. And what is quite unique in STDI, I believe, is that the way that we design STDI, its concept, the process, and also the implementation is vendor neutral. So it's not like that if you make a contract with a company, imagine with IBM or Siemens, or so, you are locked in their platform, their framework, and it's going to be very hard if you want to add some extra functionalities or bringing more stakeholders into action, because they have to be, they have to work with this specific product from a specific company. So STDI is designed considering a distributed system structure as well as being vendor neutral. And another key point is using this ISO standard in order to define the process for STDI, and the help of looking at the system from different views. And also two key characteristics is we try to set up the whole system in a bottom-up approach, which makes it easy for us to implement this integrated solution ideology. And also another point is bringing different stakeholders into the process and talking to them and understanding their roles and requirements is another important point in STDI, which I think, or I believe, makes STDI also different.
Thanks, Mandana. There's another question has arrived from Claudia. How is data maintenance and updating handled? And I guess that links into the question of what are some of the ongoing models that cities and districts can set up this sort of approach and platform and utilize it into the future? You might both have a comment on that.
Could you repeat again the first sentence?
How is the data maintenance and updating handled?
Okay. So I can start, maybe Holger can help me. One point is, for example, in this virtual district model, what we do for creating the district model, the 3D district model is, for example, again in KOP, we bought the data from Ordnance Survey, which is the national surveying department, and they have like some unique ID for each of the objects they have in the data sets. So what we did, we create this district model based on their data sets and their data, and always keep this unique ID. So whenever they update their data, we can simply update our data based on having this unique ID. For other information, like for example from the sensors, I think this information came from the data providers, and well, because normally the sensors are kind of like real-time data, so they are frequently updated in a way. So this is another point.
Yeah, maybe I can say something just for us. So we are basically not deploying, or we didn't have sensors, so live data in our system, in our platform. So for us, it's mainly the data that comes out from the workshops, and that's basically every time we have those workshops, we load or publish back the data into the database, and then it's also available to everyone who has the right to access that data. And we are providing it through different web platforms, and that data is always consistent with the main source. And
also another point is that in the structure of the STDI, these 6 different components of STDI I showed you, one is virtual district model, and as part of this virtual district model we have 3D district model. So really the objects of the districts are modeled in this 3D district model. And what makes also STDI again unique is use of this 3D district model, because it plays like it can be counted as the hub where different information are linked, because we're talking about the districts and we are dealing with the objects within the districts also. And we can also link many of the information, not all, but many of the information to these objects. And through this, using this 3D district model, it also helps us to have a more constant and frequent and reliable update of the information.
Thanks everyone, thanks a lot both. We've come to the end of the webinar. Sorry, I think I might have had a mute glitch there. Feel free to stay on those. We have a few more questions coming in, and so we're around for another half an hour or so if you wish to stay and join us. But otherwise, thank you very much for joining, and we will be sending out links to the webinar recording, the video that was played at the beginning, and PDFs of the presentations by email. So we're ending the recorded webinar there. But we do have another question from Rule, which I will read out so to make sure I get it right. Dear presenters, thank you for your presentations. I'm curious how the use of data and data analytics influence decisions made in the local planning processes. Which type of analytics were most successful and have the most potential? What are the success factors? What could be improved? And what are some of the key lessons learned?
So that was a question for both of us, right? So yes. I think from our point of view, of course the mobility analytics is was very valuable. So we can really analyze and make the redesign the mobility aspects of a district, which is a value created for not just the citizens but also the businesses, and also of course can have a high carbon impact. Another very interesting but also very difficult to solve aspect is even we know how much energy we could use per household. We have quite a trouble to implement any kind of changes because the ownership structure of the district we have, like in Moabit, is very heterogeneous, as I already mentioned, and so you can't basically refurbish a whole street. Yeah. So, but of course, it's great to know the potential, but it's very difficult to implement changes there. Yeah, I think that's from the analytics part. Of course, where it was very successful, it was the water management. So there we identified very basic solutions that could help really to make a difference in the pollution of the rivers by just implementing very low tech water buffers in case of heavy rain, and those of course will also the size of them were calculated by some simulation tool.
Thanks, Holger, for your points. What I can add is, so the lesson learned was that although the use of the data and having such bottom-up data integration framework or solution is crucial and essential for the districts to have, but the complexity of this work caused that most of the district try to kind of ignore the sensitivity of data integration. And I think we in SSD, what we learned was from the beginning we understood the importance of the data, and we try to bring it to different districts and tell them how important it is. So it's in one hand for me a lesson, but also a success, because now most of the districts, they are convinced about this point. What we need to work further is, of course, to improve and to add more data types and more functionalities, and work more on the security and the privacy aspects. And what now we're thinking of implement is to transfer the CDI or migrate into the cloud. And another success point is that I remember from the beginning of SSD, we discussed a lot and we spoke a lot about the integration solution. And I think what data brought for SSD and for the districts through the SSD was bringing this way of thinking that we don't need only to have the integration from top down, but also we need to look at the system and start this integration also from the bottom up approach.
Thanks, Madana. Maybe I can add one more thing that I find quite important also about this whole topic of like the district basically building up their own data infrastructure. I think I mentioned this already about the machine learning potential, the artificial intelligence, like the new data services that are going to be available. And I think there will be a lot of applications and a lot of services and a lot of also saving potentials using there will lots of data-driven solutions. And I think if the municipality building up either by themselves or like of course by some service provider, but basically having their hands on them, I think it's very they are in control of the landscape also of the services that are going to be developed. So they can, for example, purposely make different type of data publicly available, so to kind of boost the local businesses or entrepreneurial businesses that are maybe then using these data for their own. So I think that's also some kind of service that the city can give to their local businesses by providing certain data. So I think if in looking in the future, I think it's very important that there is a certain type of data, or there is actually as much data as possible that is possible under privacy conditions, of course, available for not just a single player, but for a landscape of companies and stakeholders. Thanks.
So one more question, both, and I guess is heading more into the implementation and the ongoing use of this. So a question around financing and what's required to adopt the solution long term.
So is it a question specifically for STDI or in general?
I think around what do cities need to do to adopt and the financing of using a platform like this longer term.
Yeah, I guess I can start, but with not a very pleasing answer, because we are basically now at the end of the deep dive in Moabit, Berlin, and we have the issue of that the data infrastructure that we developed was not now taking over one by one or one to one by the local municipalities, and I think the case is because there is like expertise, a missing expertise, so they wouldn't know how to run operate this. So I think what we also in SST need to look at is bringing this SDI concept already with a set of business models that are valid business models, so the municipality actually just need to sign up and have already like a kind of collection of services, data-driven business models available.
Jim, is it something you can comment on that you might have some ideas about where you're at and what the future holds?
Yeah, I mean, I guess it it does come down to business value in this. So we're running this, the SSD project, which is funded by the Climate-KIC as part of a research program. We believe that we found some very good use cases which will support our business. I guess the acid test is whether people in the business will want to fund such a data repository and everything which goes around it on the sort of web services and the management of that, whether they believe that that's good value for money for public funds to be spent on that. And I think that's where the SSD network is very important, because it means to say that we can all do different trials and have different use cases, but when you bring those all together, there's a sort of we can share those use cases, and there's a compelling argument for the people who hold the money within our organisations that they should invest in this sort of technology and these processes. So I think it's an interesting question, but like I say, I think it comes down to proving the business value. And it goes back to what I said before, which was the challenge now is for us, along with Tech University Munich, to find a productionized industry strength a platform for us to continue running this, and by that I mean obviously one which is affordable as well. I will say though that, as I think when someone asked why didn't we just take an off-the-shelf package, when we looked at this 2 or 3 years ago, there was no, we couldn't get this. There wasn't anything like this out in the market, and I think that whichever organisations market a supported platform for this will have a real lead, because it's something which lots of cities and districts across the world are looking to do.
That's very well put, Jim. Thank you. And I guess from my side, reasonably early days for me in the program, but certainly the challenge of how do we get from research and piloting projects to a lot more scale and impact. So taking finding solutions where they don't exist, finding solutions where they do exist, and helping, as you've both Holger and Jim, as you've said, turn those into a much kind of clearer menu of options, the key factors of business cases, so that they can be financeable and be implemented and work and have a really positive impact long term. So that's part of the journey. But so we're looking forward to that next stage. And just as wider background, the Queen Elizabeth Olympic Park project, we've got a transition workshop in planning for in a couple of weeks' time. So sort of having been through the first phase or around with Smart Sustainable Districts, looking at what might the next phase bring. So it is really that process of, that ongoing process of change, and that network and community elements that we hope are starting to deliver some dividends. So if there are, unless anyone has any other questions, I think we might draw it to a close at that point. Feel free to raise a hand. Speakers, any final comments or wrap-ups that you want to make?
I mean, it's Jim here, but I think going back to the question of financing this, I think there's a lot of projects which are coming up, which come with a lot of money, which financing data repositories and these sorts of platforms will be a drop in the ocean. So I'm really thinking about the whole connected and autonomous vehicle initiatives which are taking place. So we're looking at how we can use the Olympic Park as a platform for testing and developing connected autonomous vehicles, and the big car companies and also the big tech companies are putting an awful lot of money into this. And if we could hook what we're doing within the SSD data initiative, if we could hook that onto those projects, then like I say, I think that it would be very easy from a financial point of view to justify implementing these sorts of data systems.
Absolutely.
Yeah, I have one last comment also, because I think what is great about the SSD network is that now we developed in Moabit like four applications, right? Like maybe some more successful, some less, but I think actually they are all successful, but maybe not like business cases, let's say. But if we now each joining city is coming with like 2, 3, 4 new applications, we can have like a huge list of possible applications, like Jim already mentioned, and I think that's actually the great thing. And then STDI with the catalog service makes resources from other districts like scannable and searchable. So with this setup that Mandana developed, the infrastructure and the this kind of metadata service, I think, or catalog service, I think, it's the replicability or okay, sorry. So is very easy to access.
Yeah, I'd agree with that. I think maybe we should have a day's workshop, or at least a day's workshop, just to get together and share what we're all working on and go through it in a bit more detail. And I know that there are lots of SSD workshops, but sometimes your day job sort of gets in the way of that. But I'd feel it would be really useful to come over and see what you're doing in Berlin in a bit more detail.
Yeah, exactly. And I think we need like a platform but that's what's actually in development now. Like you said, it's in the pipeline that we have this kind of overview, very easily see what is happening in other districts.
Yeah.
Great. Well, thank you everybody for joining us this afternoon from across Europe. I think we hit 12 countries apparently at one stage, so that's very much appreciated. Thank you, Holger and Mandana and Jim, for your contributions and education this afternoon. Thanks to Martine and Arno in Utrecht, who have done a great job in setting up and organising today. And we look forward, of course, feedback, suggestions, further questions, all very welcome. You should have our details through the system, and we look forward to the ongoing conversation.
Okay, thank you.
Thank you very much.
Great afternoon.
Bye.
Thanks, everybody.